Okay, gentlemen, welcome back. Today we're going to talk about 7-2, and the good thing about this is that we've already kind of investigated this. Okay, we learned, I don't know if you remember, but we learned about the parent families of all functions. Remember the families of functions? And we did the linear and the quadratic and the cubic and the square root, the rational, all that good stuff. And remember that we shifted it using the H to go left or right and the C or the K to go up or down, and then the A would either compress it or stretch it. The good news, all of that is the same here. That's the good news. So, for properties of exponential functions, just like all functions, exponential functions can be stretched or compressed, shifted to the left or right, and shifted up or down. Let's see how it works, guys. When we're looking at an exponential parent function, it's y equals a bx. In some texts, you're going to find that the parent function is bx. I don't like that. And I'm going to tell you why I don't like it. If I were to give you, for example, y equals 3 to the x power, wouldn't you know that it's implied that 3 is the b and a is 1 in this case? Yeah. Exactly. But if I were to give you something like this, okay, a lot of people will graph just the parent. And they'll say, oh, the parent is just y equals 3x. By doing that, they're not putting into consideration the compression or the stretch here. So even though technically the true parent function is y equals bx, we're going to learn that the parent function is y equals a bx. Trust me. Where a is 1 in this particular, for the parent function, a is 1. Okay? Now, the complete exponential function would be y equals a b to the x minus h plus k. Hopefully this is ringing a bell already, because we've seen a lot of minus h's plus k's. Remember, guys, that when we're looking at this minus h, we're doing the opposite, okay? We're doing the opposite. So, let's talk about this. A represents the stretches, the compressions, and or the reflections. Just like the other parent functions. That's why I kind of think this is a very simple section, because it's very similar to the last one. If the absolute value of a is greater than 1, you've got to stretch, guys. Remember, that's going to get narrower and narrower and narrower. That's a stretch. If a, okay, the absolute value of a, is greater than 0 but less than 1, in other words, if it's a decimal or fraction, okay, I have a compression. That means that it's going to get wider. You're compressing on it. Remember the rubber band, guys. If I take a rubber band and I pull up on it, that's a stretch. It's getting narrower and narrower. If I take that same rubber band in standing position, resting position, and I squeeze it down, it gets wider, right? That's a compression. Remember the rubber band, guys. Remember the rubber band. So, okay. Reflection. If a is less than 0, if it's a negative, then you're going to have a reflection. Okay? And you're going to have a reflection over the x-axis. So, in other words, if I have y equals, whatever, 1 to the x power, it's going to be something like that, right? Roughly. And then if I go y equals negative 1 to the x power, okay, when I do that, it's going to be like this. Because it's a reflection. I reflected over the x-axis. Okay? So that's what the A is going to tell you. If the A is negative, you know it's a reflection. If the absolute value is greater than 1, you know that it's a stretch. If the absolute value of A is between 0 and 1, you know it's a compression. B is the growth or the decay factor. Please remember, guys, hold on, Bubba, that the growth or decay factor comes from 1 plus the R. When the R is positive, that's a growth. When the R is negative, that's a decay. Yes, sir. Thank you very much. That's a great question. The question was, how do you know if it reflects over the X or the Y? Okay. If I have function f of x, okay, if I make only the x negative, okay, I am going to be reflecting over, I'm sorry, I did, wait. Yeah, if I make the x negative, I am only reflecting over the x-axis. If I make the whole entire function negative, I reflect over the y-axis. Does that make sense? When I'm only affecting the x, I'm reflecting over the x-axis. When I affect the whole entire function, I reflect over the y-axis. Thank you, son. The h, just like before, it shifts left if it's positive, and it shifts right if it's negative. And the k, just like before, if it's positive, you shift up, and if it's negative, you shift down. Literally. That's the lesson, guys. So let's go ahead and investigate how this works. May I? Thank you. Okay. First things first, you make a table of values using the domain -1, 0, 1 for the parent function, okay, which is y equals ab to the x power. Number 2, draw a dashed line graph of the parent. Number 3, shift the dashed line graph shift the dashed line graph, to the left, right, up, and or down accordingly. The good news, by me incorporating this A into the first step, I have already completed all stretches, compressions, and or reflections. They have already been calculated. That's why I do it this way. If not, if you do it the way some books say, now after you found all your values, now you got to see if you have to reflect them or compress them or stretch them. And that's a pain. That's a mission. And just remember, please, that the asymptote, okay, the asymptote when you just have a plain old ABX is y equals 0, the x-axis. When I have added a k to this, guys, okay, the k is going to be my asymptote, my new asymptote. So let me explain what the heck is going on here. Number 1, I got y equals 4 times 3 to the x power. First of all, is this going to be narrower or wider than a regular exponential? Because of this 4, it's going to be narrow, right? It's going to be a stretch, right? So here, guys, there's not much to do with this one. -1, 0, 1. When x is -1, I got 4 times 1/3, which is 4/3. When x is 0, 3 to the 0 is 1. 1 times 4 is 4. When x is 1, 3 to the first power is 3. 3 times 4 is 12, okay? These graphs actually are not good. I'm not happy with this graph because it's going to be very hard for me to put all the values because I have fractions and then very large numbers. So you know what? I'm just going to go ahead and do this. Let's just go ahead and we'll just make a graph real quick, okay? All right. So let's go ahead and do this. This way we can label it our own ways. We're going to have to do some estimates, and that's okay. Estimates are okay. Estimates are okay. All right. So I've got -1 and 4/3. -1 and 4. By the way, do I have to do any shifting here? Left or right or up or down? No. So once I make this table, we're done. All we did here was a compression or a stretch, and in this case, it was a stretch. So -1 4/3. That's 1 and 1/3. 0 4 and 112. Bless you. Wow, 112 is going to be like all the way up here. So it's going to be like this. And that's it. You're done. You have no horizontal shifting, and you have no vertical shifting. Does that make sense, guys? Okay. Let's do one now with a little bit of a shift. Let me get rid of this right quick. And again, sorry about that. I didn't think clearly when I was making these graphs. Sorry. Okay. So here, I'm going to go ahead and do the procedure. First of all, what's the A in this case? No. 1. Remember, whatever is attached to the exponent, that's the B. That's my growth factor or decay factor. Gentlemen, I'm glad I asked that. So let's go ahead and make our table. -1. Let's do 0 and 1. And actually, you know what? I'm going to use a little bit of a different one here. Use your brain here. Okay? I would use 2. I would use 2, 0, and 1. Why? Well, I'm going to have to use a negative as well, though, aren't I? Darn it. Oh, no, but when it's 1... Yeah, I know. I really didn't want to use -1 here. -2 is going to be even more of a mission. You know what? Let's just stick to what we got. Let's go -1, 0, and 1. 3 to the -1 minus 2, that's 3 to the -3, which is 1 over 27. When x is 0, 3 to the -2 is 1/9. When x is 1, 3 to the -1 is 1/3. So is this going to be decay or growth? Yeah, as my x is increasing, my y is increasing. Yes, absolutely right. So okay, let's see what we got here. All right, so -1, 1/27. That's like here somewhere. Yeah, that's an estimate. I know. 0, 1/9, a little bit higher. 1, 1/3, a little bit higher. And that would be my graph. I'm not going to be too picky as long as it's reasonable, your points, because we are estimating. I don't think many people can estimate 1/27ths perfectly. Sir. Hold on. Now, do I have a shift here? Oh, but you know what? I already did that. Yeah, I already incorporated it. Yeah. No. What I didn't do is what I taught you to do. Because I don't know, man. I think I'm having a little bit of a bad day today. What I should have done is follow directions, because I'm a ding-dong, and I didn't follow directions. -1, 0, 1. Yeah, sometimes I get so mad at myself. I'm sorry. This is 1, and 1 is 3. Why don't we do it the right way, Mr. Morrow? -1, 1/3 is still there. 0, 1, and 1, 3. Right? That's my original parent. Now, I got to go to the right. I got to go to the right 2, correct? Okay. So if I go 1, 2, am I not here? Right, guys? And then here I go 1, 2. I'm about right here. And if I go, this is just off. 1, 2, it's about here. So yeah, that black one was already all incorporated. I shouldn't have done that. But as you can see, if you want to just plug in the numbers right into it, you can. Sir. No, if you just do it, if we do it the original way I did it, you don't have to do that. No. If you do it the second way, doing the parent and then shifting, then you have to shift. But I think it may even be easier just not even to shift anything. Okay, first of all, here, what's my asymptote here? 10. So I know that I'm not going to be able to pass that 10 dash mark, okay? Let's go ahead and do my parent here. Huh? Yeah, and that's my asymptote. The k is the asymptote. So negative 1, 0, and 1. When x is negative 1, I got 5 times 50, right? Which is going to be 250. When x is 0, it's 50. And when x is 1, it's 10, right? Right? So let's go ahead and do that, and then we'll add our 10 later. Unless you want to add your 10 now. Okay. So negative 1, 250. Let's make these, I don't know. Let's say negative 1 is here. Let's say this is, geez, let's go by, I don't know. Let's go by 25s. So still, negative 110 is 250 would be 1, 2, 3, 4, 5, 6, 7, 8. Okay, so it's right there. 0, 50, and 110 would be here. So that's my parent. But then what do I have to do with every single one of these? I got to shift it up 10. So I'd have to shift this one up 10, this one up 10, and this one up 10. So then it would be like that. Does that make sense, guys?
Yeah.
Okay. Give me 1 second. I'm going to revise your homework. Thank you. Give me 1 second.